Ladies and gentlemen, welcome to the recording of my motion review worksheet. This motion review worksheet has 4 problems. On each one, it gives you a situation of how the object is moving and asking you to draw graphs of the position time, velocity time, and motion map. So let's get started. On the first one, it's asking you to draw the graphs for an object moving at a constant velocity away from the origin. So if we look at the position versus time graph, this one's we're pretty comfortable with. This is like our buggy graph. We're going to start at 0 position and 0 time. So we're going to start at the origin, at the start line, and then we're going to move away at a constant velocity, which means the slope of our line is going to be a straight, unchanging slope. And if we took the slope at any 2 points on this line, it would give us the same value. So that's moving away from the origin at a constant velocity. When we come to the velocity time graph, we have to remember that up here above the 0 velocity line is away from the origin by convention. And down below is towards the origin. And we just have to sort of memorize that one. And so this one is moving away from the origin, so it has to be up here. It's going to be constant velocity, so it's going to be a straight line. Now, if you want me to help you with that, just think about it this way. Here's 0 velocity here, here's some non-zero number, and at any time we can go up there and it has the same velocity. So no matter what time we check, it's always going to be at the same velocity. So that's how that looks. Motion map, we're going to start at the origin. So here's the origin here at 0, and it's going to move away at a constant velocity. And I'm going to do my best to make these be evenly spaced dots and moving away from the origin. They look even to me. All right, let's go on to number 2. Number 2 says draw an object moving at a constant velocity toward the origin. So here is the 0 position, 0 time. So if it's going to move towards the origin, it has to start away from the origin. Constant velocity means the same slope throughout, and so I have a line that is moving towards the origin. It's getting closer to 0 position, and time always goes on, so that's what that looks like. Now, we come over to the velocity time graph, and this is away from the origin on this side, and this is towards the origin on this side. So we know this one's moving towards the origin, so it has to be below the 0 velocity line. And again, that just means that this down here in velocity means it's going towards the origin. And this has a constant velocity, so that means no matter what time we check in, it's always going to be the same distance away from the 0 velocity line. And that's what that looks like, constant velocity, always the same. And if we look at the motion map, again, it's going to start away from the origin, and it's going to move away towards the origin at a constant velocity. I will try to make these dots be as evenly spaced as I can, and they're going to do that until they get to the origin of the motion map, right there. Let's go on to number 3. This is the acceleration case. This is decreasing velocity toward the origin. So that means on the position time graph, I have to start away from the origin. And if it's decreasing velocity, then I know that the slope of that line needs to get flatter and flatter as I move on. So away from the origin, I start moving towards the origin, but I know that it has to slow down, so the slope of that line has to get flatter and flatter, and that's what that looks like. Now, when we come over to the velocity time graph, again, I'm going to write it again. This is away from the origin on this side, and this is towards the origin on this side. It's just important to remember that convention. And I know that it's going to be decreasing velocity, so it's flattening out. Here on this line right here is the 0 velocity line. So it has to start sort of some non-zero number in the towards the origin side, and it has to move towards 0 velocity because it's slowing down. So that line is going to look something like that. Now when we look at the motion map, it has to start away from the origin, and as it moves towards the origin, it's slowing down. So I'm going to draw a couple of lines, and as we get closer to the origin, they get closer and closer. Now we're going to go on to number 4. This is going to be a case of acceleration. It's going to be increasing the velocity toward the origin. So that means I got to start on the position time graph. Here's 0 position. Here's some distance away from the origin. I have to start away from the origin, and as time goes on, the slope of this line must get steeper and steeper because the velocity is increasing, and that line will look something like that. Now when we come over here, let's remind ourselves that this is away from the origin on that side, and this is towards the origin on this side. And so we're going to start at some velocity that's near zero velocity, so it's very slow up here, and it's going to move away from zero velocity as time goes on. So that is increasing velocity toward the origin. Again, here's zero velocity, so anything down here away from zero means it's getting faster and faster. And don't let the negative side fool you. This just means away from the origin. This is towards the origin. And if we look at the motion map, this is increasing velocity towards the origin, which means I have to start out here, and I'm going to move towards the origin. At first, my dots are going to be close together, and as I move on, they're going to get further and further apart until I get to the origin. And that is our motion map review video. I hope that helps you, and I'll see you soon.